Hey guys, and welcome to the video. In this session, I want to discuss how we can use multiple try and excepts to cover a single batch of code. And to show kind of why this is important, let me take you through a simple example here. Suppose we have two variables, these are just our inputs, so we ask the user to enter A and B. We then set up a result variable, which is equal to int of A divided by int of num_B, and finally we print it. Now, there's actually multiple ways. This bit in particular, I know potentially you could break this here, but just focusing on this bit for a second, there's actually many ways you could break this. So let me just run this and show you what I mean. Suppose I did 10 and 0. We get this 0 division error, of course. You can't divide by 0, so that can go wrong there. Or we could also enter things which are inappropriate for it to be converted to an integer, right? So, if we pass in something like this as a string, like converting something like this to an integer is fine. However, suppose we ran this again and we did, let's do 10 and I don't know, maybe we enter 5 like this here. Let's see what we get. We get a value error. So value error basically means a function has been given something that's the correct type, but the way that value has come in is inappropriate. So in this case here, int can accept a string version of 10, like 10, but it can't accept a string version of like FIVE, so it raises this value error here. So basically there's two ways this could go wrong, and you could just do a blanket try and accept, but let me show you what the problem is with that. If I just did try, let's see, yeah, I'll do them both for the same thing. So if I bring these both inside here, and we'll do accept, and then we'll just do print. An error has happened. So something, a bit vague, but you get the point. So a blanket try and accept. Now let's see what happens here. If I do 10, 0, that's fine. Of course, an error was raised here, so therefore we jump to the exception and we see this. Now let's try and do the other one. So if I do 10, 5, an error. So how do we know which one happened? I mean, of course, I know at this point we can physically see the code and it's fine, but especially in practice, there's way more complex examples where if you do these blanket exceptions, it's just not quite good enough. In practice, in work, what we effectively have to do is we have to catch specific errors here, and then we can then log specific errors out. So if you import the traceback module here, you import traceback. It's actually a pretty cool little function you can do. You can do traceback. Let's see, .format, exact like this here. Let me show you what this does, because this is kind of cool. If I hit run, do 10, 0 here. So in this case here, it's a fairly simple error, so it catches it fine. But if this was some complex error that gets raised and re-raised, etc., or an exception happens whilst trying to make this exception happen, this is basically like a thing which kind of prints off the full error stack. So just something to bear in mind. I often try and include this if I'm doing a fairly complex try and accept, kind of putting this in, especially where if your code is writing to a log file, put this in, and it's a nice kind of clear way to show what's happening. It just kind of returns this big string with all the error, the line number, etc., and where it happened, and the error class it belongs to as well. So just something to bear in mind. I'm going to get rid of that for just a second. I'll remove it from here. So, the way you would deal with this in practice is, suppose you wanted to do, you want to do one thing for a 0 division error or something else for a value error. Then what we then do is you kind of stack them here. So you can do 0 division error, do this, or you can do except, do value error. What I can do, if I do these prints here, put this guy underneath. Now if I just do, just to show it kind of going through these. Value. Block capitals, I don't mean to be angry code, but you get the gist. Okay, let's do the 0 division first. 10, 0, so see how do we get an error, 0 div? That's because we have basically said, okay, in this section, we have caught a 0 division error, so therefore we do this one here. So basically, this flow of execution only happens when this is caught. On the flip side, we can also then do the other one here. So if I do, there we go, an error, value error here. So that's which in my view is probably one of the best ways of doing it. So you can try and catch them kind of one by one. But of course, that does come to the argument of if you're doing something fairly complex, you have to be aware of all the possible errors that can happen in this bit here. So my advice for that would be try and keep whatever is in your try section small, concise, and make it so it can't possibly raise that many errors. So if you're making a request to an API, you might try and catch off any requests that involve connections, or if this is opening a file, you might look for a file not found error or an OS error or something like that. So really just keep this bit as small as possible, figure out what are the possible errors that could go wrong in here, and then catch them individually. If for whatever reason, what you can actually do accept exception, and then you can then do, this is, again, I probably wouldn't recommend it, but if you were in a situation where you really couldn't figure out what else is going to happen, you could theoretically do that. So, trust, I'm not entirely sure what else I could raise here, but I think it could just be a zero division and a value error. But yeah, if this was slightly bigger here, and you were convinced that these two are definitely possible, but I think there might be something else that could go wrong, you would generally then come along and do like a blanket exception at the very end. So what I'll probably do in that case is do your traceback.format exec here. That's it really. That's what I would try and do. So in this case here, I might say let's remove this guy here. So we can say we can't divide by 0 and this value over here. So in this case we could say ensure both values are passed as numbers. There we go, like that. So let's just quickly try and run those top two. So I do 10, 0, we can't divide by 0. Yeah. Well done, happy with that. And then let's try and break it that way. There we go. Ensure both values are passed as numbers. And then we have it. So it's a fairly small one today, but let's just quickly do a recap from top to bottom here. My code to test this simply asks to take in two numbers, in this case, value A, value B. This variable is going to try and convert those to integers, divide them, and print off the result of that division. But as we've established, there are two things that could go wrong during this. We could pass in inappropriate values to the int function, therefore raising a value error, or we could pass in a 0 as our divisor in this case, which would raise a zero division error. So when that happens, we can simply stack our accept statements here, and then try and catch them accordingly. Benefit of that, of course, is we're not just saying if anything goes wrong, do this. It's good to be kind of specific and to the point, so we can say like, if this goes wrong, here is exactly what I want you to do, or if this goes wrong, I want you to exactly do this. We also looked at this traceback.format exec as well, and this is basically a nice way to print off the entire error stack. Generally, this is more for more complex bits of code, so like opening files, talking to APIs and databases, etc. But there you have it. Hope that's helpful, guys, and I'll see you all in the next video. Cheers.